Now we're going to dive a little deeper into the mechanics of brute force attacks. In the real world, brute force attacks aren't as simple as cycling through combinations due to protections and security measures in place to prevent such attacks. Websites and servers often limit the number of attempts a user can make to log in, or introduce delays between attempts to significantly slow down the brute force process. For a deeper understanding of brute force attacks, it's important to consider the key elements that influence its effectiveness. 1. Password complexity. Combinations of letters, upper and lower case, numbers, and special characters create a vast array of potential passwords. The more complex the password, the larger the set of possible combinations, making brute force attacks more time-consuming and less likely to succeed. 2. Password length. The longer the password, the greater the number of possible combinations, significantly increasing the time required for a brute force attack. 3. Rate limiting. Many systems limit the number of login attempts allowed in a specific period. This can drastically slow down or effectively nullify a brute force attack. Now, we're implementing a brute force password cracker for an imaginary system that doesn't have protections against such attacks. We'll use a hash function to simulate a real-world scenario since passwords are typically stored as hashed values, not plain text. In this script, we first define a function hash underscore with underscore SHA-256 that takes a string and returns its SHA-256 hash. This simulates the way passwords are often stored in databases. The brute underscore force function works similar to our previous version, but with two crucial differences. 1. It works on hashed passwords, comparing the hashed attempt with the target hash instead of a plaintext password. 2. It only returns a result when it finds a match. If no match is found within the specified length and char set, it returns none. The usage example uses a char set of ABC123 and a target hash of a known password, BCA. We hash BCA using our hashing function, then pass the resulting hash to the brute underscore force function. If all goes well, our brute force function should successfully crack the hashed password, returning BCA. Remember, this example is extremely simplified. Real-world brute force attacks would need to contend with much larger char sets, much longer passwords, and protective measures like rate limiting or account lockouts. This demonstrates why we need strong, complex passwords. They significantly increase the time and resources required to crack them with a brute force attack. Stay safe out there, and stay tuned for our next video where we'll continue exploring cybersecurity.